This video is on center of mass. Question number 1. Use the equation x center of mass equals sigma x sub I m sub I divided by m sub I to determine the center of mass of 4 objects on a horizontal line. So we are given the mass of each object and the location of each object. So we're going to use this equation. In the numerator, we're going to multiply the position of each object by its mass, add them all up, and then divide by the total mass. So our answer here is 6.23 meters. Now what exactly does that mean? That means if we put our finger at 6.23 meters, the torque on that is going to balance where the torque is 0, meaning it's not going to rotate to the right or to the left. It's the center of mass. Question 2, same problem. We're going to use the equation x center of mass equals sigma x times m divided by m to determine the center of mass of 4 objects on a horizontal line. So we're given the mass of each object and its location. This is a one-dimensional problem. The solution here is 7.12 meters. You see, the mass of each object is multiplied by its position and divided by the total mass. This means if we have our finger on 7.12 meters, this object's going to balance. Remember, this is a one-dimensional object. This is just a line. All the masses are on a straight line. Question 3, we're going to use this equation in 2 dimensions to determine the center of mass of 4 objects on a horizontal plane. So we could delete this word horizontal because it doesn't make much sense. It's on a plane. So we have each mass of the object and its position. So we're going to use x center of mass to find the center of mass on the x-axis. Then we're going to use this equation for y center of mass to find the center of mass on the y-axis. So if we put our finger at this point here, x equals 0.692, y equals minus 1.23, this plane is going to balance and it's not going to fall. Question 4, we're in the same situation. We are on a plane, like a sheet of paper. We have 4 objects. We know the mass of each object. We know the position of each object. And we could find x center of mass. We could find y center of mass using these equations. And then we could find the center of mass of these 4 objects. And the solution here is 1 comma minus 2.85. Question 5. A 2-dimensional object as shown below can be seen to be made up of 3 rectangles. The object has a uniform density. Each square has a mass of 2 grams and length of 1 centimeter. Calculate the center of mass of each object. So you could see we have 3 objects. You have 5 by 9, we have 28 by 8, and we have 9 by 7. So the horizontal distance has 5 squares. The vertical distance has 9 squares. The horizontal distance here has 28 squares. The vertical distance here has 8 squares. So we want to find the center of mass of the object. It should be somewhere in the middle, yes? So step one, calculate the total mass of the objects. So we could break it up into three parts. This 5 by 9, this 28 by 8, this 9 by 7. So each square has a density of 2 grams per centimeter squared. So we get a total mass of 664 grams. Step 2, determine the center of mass of each block. So we're going to say that the origin is going to be here at the bottom left. To the bottom left of this 28 by 8 rectangle, that's 0, 0. So block 1 has a center of mass of 2.5, 13.5. So block 1 is this block here, the 5 by 9. So if you go 2.5 to the right and 13.5 up, we're going to have the center of mass of this block here on the top left. This rectangle on the bottom, the big one, it's gonna, sorry, block 2, which is on the top right, this 9 by 7, its center of mass is going to be 23.5, 11.5. Meaning, if the origin is on the bottom left and we go 23.5 to the right, 11.5 up, that's the center of mass of this 9 by 7 block. And finally, this big rectangle on the bottom, 28 by 8, its center of mass is 14, 4. So, let's calculate the x center of mass. This is 2.5 centimeters, which is the center of mass of the block on the top left. This is 23.5 centimeters, which is the center of mass of the block on the top right on the x-axis. And this is 14 centimeters, which is the center of mass of the big block on the bottom. And then the denominator is the total mass of all three objects. So for the x center of mass, we get 14.2 centimeters. For the y center of mass, you could see this big numerator and denominator here. It's the same as the x center of mass, except we're going to replace the x center of mass with the y center of mass. Here's the x center of mass, 23.5. This is the y center of mass, 11.5. Here's the x center of mass, 14. Here's the y center of mass, 4. So we get the solution 14.2, 6.7. So this is another very similar problem. A two-dimensional object, as shown below, can be seen to be made up of three rectangles. The object has a uniform density. Each square has a mass of 3 grams and length of 1 centimeter. Calculate the center of mass of the object. So step 1, calculate the total mass of the object. We know the density of each square is 3 grams per centimeter squared. In this big parentheses, we have the total area of the 3 blocks. And we get 279 grams is the total mass of these 3 blocks. Step 2, determine the center of mass of each block. So we got 3 blocks. And let the bottom left corner be of the largest object be the origin. So right here to the bottom left of 22 by 3 rectangle, that's going to be the origin. So for block 1 on the top, the center of mass is 3.5, 5. So it's here. For the big rectangle, the center of mass is 11, 1.5. So it's in the middle here, like this. And finally, for block 3, the center of mass is going to be 15.5 comma minus 1.5. So it's going to be down here, down here. And now, step 3, we're going to calculate the center of mass. We know this equation. So we're just going to plug in what we know. So this, we're going to use the x coordinates. And for this equation here, we're going to use the same mass, but we're going to use the y coordinates. So our center of mass is 10.76 comma 1.47. So if I put my finger at 10.76 comma 1.47, I would be able to balance that object. Question 7. A rectangle with a uniform density as shown below has a circle removed from it. Each square has a mass of 1 gram and a length of 1 centimeter. Calculate its center of mass. So the center of the hole is 17.5 comma 4.5. Let the origin be the bottom left of the rectangle. So that's here on the bottom left. The total mass of the rectangle without a hole cut in it is this, 208 grams. The total mass of the circle, assuming it is not an empty hole, is this. So this circle, if it did have a mass, it would be this. The center of the mass of the rectangle is this, assuming there was no hole. The center of mass of the circle is this. Now remember, for problem 1, 2, 3, 4, 5, 6, this sigma would always mean add. But since there's a hole here, an area with no mass, we're going to subtract. You see, we're subtracting. So x is displacement, m is mass. Here we have displacement times mass. Here we have a minus sign because we're subtracting the hole, the circular hole. Same thing with the y, we're subtracting the circular hole. So the center of mass is now 12.53 comma 3.95. So the center of mass is to the left of 13 because 13 is halfway, and it's 3.95, so it's below 4. So that makes sense since this circle is a little bit above. It makes sense using our intuition. Question 8. A two-dimensional circle has a circle cut from it. So this big circle has a mass, this small circle has no mass. It's empty. Determine its center of mass. Each square has a length of 1 and a mass of 1 gram. So the total mass of the large circle without a hole cut in it is this, 78.5 grams. The total mass of the circular hole, assuming it is not an empty hole, is 3.14 grams. So this circle, this small circle, if it does have a mass, it has a mass of 3.14 grams. So the center of mass of the large circle is 0, 0, just the middle. Bloop. The center of mass of the hole is going to be 0, 4. So x center of mass, we're going to get this. Now remember, there's a minus sign here because there's a missing mass. We're not adding. Same thing with y. So the center of mass is going to be 0, negative 0.167. And that makes sense because the center of mass on the horizontal axis is going to be 0. The center of mass on the vertical axis is going to be below 0 because there's missing mass on the top. So that's why it's going to be below zero, not above zero.